In this video, you will learn about the important tips for data analysis. When we use the measures of center tendency and when measures of dispersions have meaningful value. And what 5 numbers on details us basically. So let us start with the simple measure of center tendency. In this graph, you can see two colored lines. One is red and other is black. These two portions are seems similar pattern or shows identical shape. So they have the same mean, but the measure of center tendency lie on different point in these two shapes. We can't say they have the same mean. Identical shape, the black is centered to the right of the red. So here you can see the red portion is different from the black, but they have identical shape. Here black is centered to the right of. Similarly, here you can see measures of center tendency are used to describe the typical member of a population. Why? Because this tells us about the center of the data set, either where it exists. So depending on the type of data, we choose appropriate measure as we discussed in detail, triple M lectures. So here we can see some review of measure of center tendency. So appropriate measure of center tendency are mode, if the nominal variable or the data is qualitative instead of quantitative. So we prefer to use the mode. And when we have the level of measurement ordinal, we shift our measure of center tendency towards the median, as this describe more useful results in case of ordinal variable. And whenever we have the level of measurement interval or ratio, we prefer to choose the mean. And mean is also applicable for the normal distributions, as whenever we have the normal curve, we prefer to choose the mean. And whenever we have the skewed distributions, the appropriate measure of center tendency in that case is the median, because median gives us the central value of an array. So extreme values that the outliers can overcome in median. So mean is only meaningful whenever we have the level of measurement, either interval or the ratio. Mean is the meaningless quantity in case of qualitative nature of the variable, or whenever we have the data on the nominal or on the ordinal scale. So mean gives us meaningful results only for the interval and ratio level of measurement. Whereas median is applicable are the more meaning give us more meaningful result in case of skewed distributions, and valid for the ordinal, interval, as well as ratio level of measurement. Whereas mode have the characteristic which fulfill all 4 levels of measurement, including the nominal too, because according to the definition of mode, we pick the highest or the most frequent value. So in nominal case, we can also pick the most repeated value. So mode is appropriate or the most suitable for the bimodal distributions. So whenever we have the normal trend, the appropriate measure is the mean. And whenever we have the skewed distribution, either it is positive or the negative, whatsoever is the type of skewness, we prefer to use the median. And for the bimodal distribution or bimodal situation, we prefer to choose the mode. So these 3 measures of center tendency have different applications. Now we have one question in our mind: why can't the mean tell us everything? So the answer is very simple. As mean described the measure of center tendency and what is the average outcome is. So we also want to know something about how accurate the mean is when making predictions. Like the question become, how good a representation of the distribution is the mean? How good is the mean as a description of center tendency, or how good is the mean as a predictor? So to answer this kind of question, this is very simple. It depends on the shape of the distribution. Is the distribution normal or skewed? So once we know the shape of the distribution or we identify the shape of distribution, we can easily choose the appropriate measure of center tendency, and mean is not uh, always useful or preferable over the other measures. It depends upon the characteristics upon the type or the level of measurement. So accordingly, we choose the suitable measure. In this figure, you can see the concept of measure of variations are the measures of dispersion, what they tells us. So here you can see X and Y are the two variables. So this light purple for the X and this dark purple for the Y. So here you can see they have the same mean. Both X and Y series have the same mean, but Y varies more than the X. So variation in Y is more as compared to X. So their measures of dispersion or measures of variations gives us different results for both series, even though we get the same mean. You can see on average maximum average values lie here. So X and Y have the same mean, but it doesn't mean if they have the same mean, their variation must be same. Here you can see the variation in Y is more as compared to the variation in X. So here Y varies more than X. So we know that the measure of variation, we choose different tools like variance, standard deviation, range, coefficient of variations, coefficient of quartile deviations, and so many measures of variations exist. So we choose according to our requirement and apply on it and find the variation and interpret it accordingly. So here you can see the graph or the example of quantiles, what it tells us. We have three main types of quantiles known as quartiles, deciles, and percentiles. In quantiles, basically we divide a number line into equal parts. So if we divide the number line into two equal parts, it is median. And if we divide the number line into four equal parts, we get the quartiles. And we have the three quartiles, Q1, Q2, and Q3. Similarly, if we divide the number line into 10 equal parts, then we can get the deciles. And if we divide the number line into 100 equal parts, we get the percentiles. So here you can see the concept of quantile. On the middle, we have the 50th quantile at 0.5. And on the left and right, we distribute equally the remaining values. So we will discuss the detail of quantiles in our next lecture. Here are some examples of mode. Here you can see this distribution dies through. The first example is unimodal. So in this case, you can see the graph seems almost normal trend. So in case of normal distribution, the appropriate measure is the mean. So on the basis of mean, we can interpret this dice through example. But here, when we have the bimodal distribution, the most appropriate measure of center tendency is the mode. Like this in second example, adult human weight, you can see this is the mode and this is the submode. So in this case, we have to choose mode instead of mean and median. So here you can see the concept of skewness. Basically, skewness tells us about the shape of the distribution. Either it is normal on the left tail or the right tail. So if the distribution is left tail, we can say this is the negatively skewed. And if the distribution is right tail, we say this is the positively skewed. Like you can see in this example, mode is at the peak. So here is the mode and mean is the average value, and we can see the mean roughly exists here, median is the middle value, and middle can be exist here. So in negatively skewed distribution, if we choose the relation of measures of center tendency, then by this quantity, you can easily find skewness, type of skewness. If mean is less than, median is less than mode, you can say this is the left tail. and the negatively skewed distribution. Similarly, if you have reverse of this, or you can say mean is greater than median is greater than mode, then the tail shift towards the right, and we can see this is a positively skewed distribution. And when we have mean median mode at the same point, the peak is known as median, peak is also known as mean, then we can see this is a symmetrical distribution, and there is no lack of symmetry, this is symmetric. And in this case, we choose, we can say this is the normal curve, and the appropriate measure can be used as a mean. But whereas in previous two, we choose the median to interpret or get more fruitful results, or to conclude more fruitfully results now on the basis of median. And here you can see mean, and in bimodal situation, the mode is the most suitable measure. Now, we will discuss about the 5-number summary. What is it? Actually, in many cases, discrete and continuous, we have different ways to sketch the graph, to identify the shape of the distribution. So we choose the 5-number summary plot. 5-number summary plot, basically known as box and whisker plot. And why we say this is the 5-number summary? Because here we choose the 5 numbers Q1, Q2, Q3, minimum and maximum values. So with the help of quartiles and minimum and maximum value of the data series, we can easily judge the shape of the distribution, and these 5 numbers are known as the 5-number summary plot or the box and whisker plot. So what this tells us basically, this tells us about the shape of the distribution, about the pattern of the distribution, about the symmetry and the lack of symmetry. So we draw it. Here you have to take the minimum value, and here you have to take the maximum value. You have to draw a line, and here you have to plot the whisker. That's why we say this is box and whisker plot, because this box and here we have the whisker, and basically box and whisker introduce this plot. So we say this is box and whisker plot. This whisker and this box. How we draw this box? There is no hard and fast rule to draw the box. Simply you have to identify these 3 measures, Q1, Q2, and Q3. So first you have to draw Q1. This line is the Q1, and by measuring an appropriate scale, you have to draw Q2 here and Q3 then. So if Q1, Q2, and Q3 are equally different from each other, then this partitioning is same. You divide this into 2 equal parts. So in case of symmetry, the difference between Q3 and Q2 and Q2 and Q1 are the same, are the equal. Means if we take this half difference and this half difference, they gives us the equal quantity. So this portion is Q3 minus Q2, and this portion is Q2 minus Q1. If they are the same, we can see the pattern or the trend is symmetric. Whereas if this quantity gives us greater result, as this Q3 minus Q2 is greater and Q2 minus Q1 is less, so in that case, our shape of the distribution becomes positively skewed. Similarly, if we have the reverse case, Q3 minus Q2 is less than Q2 minus Q1, then we have the negatively skewed. So it is very simple to construct. What you have to do, you have to take the minimum value here, maximum value here, then you have to identify these 2 quantities, Q3 minus Q2 and Q2 minus Q1. Once you get the answer of these 2 quantities, simply you have to draw these on the box and partitioning according to this. If they have equal, definitely the partitioning must be from the center. And if this portion is greater, you have to partition this less and greater portion assigned to this. And if the situation is like this, then you have to less for this and greater for Q2 minus Q1. So this is all about the box and whisker plot. Now there is some queries when we have to draw or sketch the box and whisker plot. Many of us make mistake in this. Basically, box and whisker plot is not for the continuous series. This is only for the discrete. And whenever we have the discrete, the whole numbers data set, and we want to check the shape of the curve, or we want to judge where it exists, either it is symmetric or lack of symmetric. So to draw or sketch discrete kind of series, we need the box and whisker plot, as this is not applicable for the continuous case. For the continuous case, we have these curves to judge the shape of the distribution. So if the distribution is continuous, we have to draw curve like this instead of this box and whisker. So whenever the data is discrete, only then we make the box and whisker plot. And when we have the data in continuous form, then we make a curve. If the curve shows this pattern, this is symmetric normal curve. And if this is right tail, positively skewed. And if it is left tail, then this is the negatively skewed. So for continuous case, we have to draw the curve on the pattern of skewness, and for discrete, we have to draw box and whisker plot. So even though both are related with the 5-number summary, here you can see we can also use the quartiles to draw the shape of the curve. Previously, we discussed the mean median mode relation to find the shape of the distribution. And here you can see we have the quartiles and the 5-number summary to determine the shape of the distribution. So here you have to calculate 3 quartiles, and on the basis of quartiles, you can partitioning this continuous line. If the difference is same or the equal, our two quantities are equal, then you can see the curve is normal or the symmetric. And if this portion is greater than this, then curve shapes like this. And if you have reverse relation, then the shape becomes negatively skewed. So this is all about the 5-number summary plot, or how we can determine the shape of the distribution on the basis of quartiles. So make it sure if your data is discrete, only then you have to draw the box and whisker plot. But whenever you have the continuous curves, even though you are using the quartiles relation, you are not, the suitable way is not the box and whisker. In that case, you have to draw curves like this. So here you can see the concept of outlier. What is it basically? On the basis of these quartiles, you can also find this outlier. Outliers mean the extreme value, which is differ from the other series. It can be either on the start or on the peak. So this is the most extreme value, which differ from the series. Like here you can see this is our box and whisker, and here is some outlier. So this is the extreme case, and how you can find outliers on the basis of box and whisker plot. So the quartile of a data set can also be used to assess whether the data set has any outliers. So to determine the outliers, you have to find upper fetch and lower fetch. Once you find the upper fetch and lower fetch, the quantities which exceed these limits are known as outliers. Like in this example, we can see this is our outlier. So next we have the kurtosis. The difference between skewness and kurtosis is skewness basically gives us the shape of the distribution or tells us about the shape of the distribution and nothing more. But whenever we want to see the peak of the distribution, for that we need the kurtosis. So kurtosis is the degree of peakness of a distribution. And we have 3 types of kurtosis. You can see here. This is one kind, this is the second kind, and blue line is the third kind. The green lines tells us mesocultic, as this shows normal trend, like normal curve in, you can say normal curve in the skewness. And here red line. In red lines, you can say this is leptocultic, as it is more white than the meso. And in platycultic, you can see the spread is totally changed. So kurtosis is used only to know the peakness of the distribution, or used to determine the peakness. Where is it exist actually. So we have beta 2 for the coefficient of kurtosis, and if this is equal to 3, then we can see this is normal, which you can see in the green line in this figure. And when this is less than 3, you can see this is the blue line, platycurtic, and when this is greater than 3, this is lactokurtic. So this is the concept of kurtosis, and this measure is known as normal. So this is all about the data analysis are the appropriate tools which we use to calculate the measures of center tendency. So make it sure whenever you have normal curve, only then you can easily interpret your series on the basis of mean. But the restriction is still that the data must be in form of quantities instead of qualities. So whenever you have qualitative nature of the series, the most appropriate measure is the mode. So you can use the mode whenever you have the qualitative series. And similarly, you can choose the 5-number summary, but make it sure box and whisker plot is only applicable whenever you have the discrete series. But whenever you have the continuous data set, box and whisker is the meaningless. So to make sure data meaningful, to get the fruitful results, or to conclude your results meaningfully are practically and statistically significant, try to choose appropriate measure accordingly. So once you choose the appropriate measure, you can easily conclude your series, you can easily conclude your data set, and the result speaks itself. So this is all about the data terms and some tips related to the measures of center tendency when you choose these measures according to different situations. Thank you.